Imagine you're walking across a park and there's a large pond right in the middle of your path. You can't walk straight through the water, so you walk 50 meters along one edge, turn at a 70-degree angle, and walk another 80 meters around the other edge to get to the opposite side. Here's the question: what is the exact straight line distance across that pond? If this was a perfect square corner, a 90-degree right angle, you could just use Pythagoras' theorem. But because the corner is 70 degrees, we cannot use Pythagoras. So how do engineers, navigators, and top exam students find that exact distance? That's where the law of sines and the law of cosines come in. They are two powerful tools in trigonometry that allow you to calculate missing sides and angles for any triangle, no matter its shape. And in this video, we are going to master both of them step by step. Hi, welcome to my exam revision. In this video, we'll be looking at the law of sines and the law of cosines. This lesson is divided into three sections. In the first section, we'll learn how to use the sine rule to calculate missing sides and missing angles. In the second section, we'll look at how to find missing sides and angles using the cosine rule, and we'll cover the decision rules so you know exactly which formula to pick in an exam. In the third and final section, we'll work through a more complex past paper question that combines both rules in a multi-step exam context.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now let's get started. Before we start using any formula, we must make sure we label our triangle correctly. In non-right angle trigonometry, we label the three vertices or angles using capital letters A, B, and C. The side directly opposite angle A is labeled with a lowercase a. The side opposite angle B is lowercase b, and the side opposite angle C is lowercase c. Notice how each letter pair sits directly opposite each other across the triangle. The sine rule is a fundamental formula that relates the sides of a triangle to the sines of their opposite angles. When you are looking for a missing side, we write the formula with the side lengths on top. A over sine A equals B over sine B equals C over sine C. Keeping the unknown side at the top of the fraction makes the algebra much simpler. Now, when do we use the sine rule to find a missing side? We use it whenever we know two angles and one side. Let me work through an example. In triangle ABC, angle A equals 40 degrees, angle B equals 60 degrees, and side A equals 10 centimeters. We are asked to find side B. We follow 4 clear steps for every question. Step 1. Identify the known values. We have side A equals 10 centimeters, angle A equals 40 degrees, and angle B equals 60 degrees. Step 2. Write the formula. Since we are looking for side B, we select the two matching parts of the sine rule. A over sine A equals B over sine B. Step 3. Plug in the values. 10 over sine of 40 degrees equals B over sine of 60 degrees. Step 4. Solve for the missing value. To isolate B, multiply both sides by sine of 60 degrees. B equals 10 times sine of 60 degrees divided by sine of 40 degrees. Substitute the trigonometric values from your calculator. Sine of 60 degrees is approximately 0.866 and sine of 40 degrees is approximately 0.642. B equals 10 times 0.866 divided by 0.642, which is approximately 13.5 centimeters. So the missing side B is approximately 13.5 centimeters. Now what if you are asked to find a missing angle using the sine rule? When finding an angle, we flip the entire formula upside down so the sines of the angles sit on top. Sine A over A equals sine B over B equals sine C over C. We use this form whenever we know two sides and one non-included angle. Let's look at another example. In triangle ABC, side A equals 10 centimeters, side B equals 14 centimeters, and angle A equals 45 degrees. We need to find angle B. If you want to try it yourself, you can pause the video and try it out. Now let's follow our 4 steps. Step 1. Identify the known values. We have A equals 10 centimeters, B equals 14 centimeters, and angle A equals 45 degrees. Step 2. Write the formula. Sine B over B equals sine A over A. Step 3. Plug in the values. Sine b over 14 equals sine of 45 degrees over 10. Step 4. Solve for the missing angle. Multiply both sides by 14. Sine b equals 14 times sine of 45 degrees divided by 10. Using your calculator, sine of 45 degrees is approximately 0.7071. Sine b equals 14 times 0.7071 divided by 10, which equals 0.9899. To find angle b, take the inverse sine inverse of both sides. B equals inverse sine of 0.9899, which is approximately 81.6 degrees. So the missing angle B is approximately 81.6 degrees. That completes section 1. You should now feel confident using the sine rule for both missing sides and missing angles. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, My Exam Revision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths, and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now, let's continue to the next part of the video. Now, what happens if you do not have an opposite pair needed for the sine rule? That is when we turn to the cosine rule. The cosine rule works for any triangle, whether acute, obtuse, or right-angled. To find a missing side, the cosine rule is written as c squared equals a squared plus b squared minus 2ab cosine c. Now remember, we use this formula only when you know two sides and the angle between the two sides, and you need to find the third side. Please remember, the angle that we need to plug in should be between the two sides that are already given. Now let me look at an example. In triangle ABC, side A equals 5 cm, side B equals 7 cm, and angle C equals 60 degrees. Find side C. Let's apply our 4 steps. Step 1. Identify known values. A equals 5 cm, B equals 7 cm, and angle C equals 60 degrees. Step 2. Write the formula. C squared equals A squared plus B squared minus 2AB cosine C. Step 3. Plug in the values. C squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 60 degrees. Step 4. Solve for C. Evaluate each term. Cosine of 60 degrees equals 0.5. C squared equals 25 plus 49 minus 70 times 0.5. C squared equals 74 minus 35, which equals 39. Now take the square root of both sides. C equals the square root of 39, which is approximately 6.24 centimeters. So side C is approximately 6.24 centimeters. Now what if you know all three sides and want to find a missing angle? How do we do that? If you know all three sides, we can find an angle using this rearranged version of the cosine rule. Cosine C equals A squared plus B squared minus C squared all over 2AB. Here is the golden rule to remember. The side being subtracted in the numerator, side C, must be the side directly opposite the angle C you are trying to find. Let's solve problem 1 from our notes using this form. In triangle ABC, side A equals 7 cm, side B equals 8 cm, and side C equals 9 cm. Find angle C. Step 1. Identify known values. A equals 7 cm, B equals 8 cm, and C equals 9 centimeters. Step 2. Write the formula. Cosine C equals A squared plus B squared minus C squared all over 2AB. Step 3. Plug in the values. Cosine C equals 7 squared plus 8 squared minus 9 squared all over 2 times 7 times 8. Step 4. Solve for angle C. Cosine C equals 49 plus 64 minus 81 all over 112. Cosine C equals 32 over 112, which is approximately 0.2857. Take the inverse cosine, cosine inverse. C equals inverse cosine of 0.2857, which is approximately 73.4 degrees. So the missing angle C is approximately 73.4 degrees. Now, how do you instantly decide which rule to use in an exam? Here is the exact summary to keep in mind. Use the sine rule if you are dealing with two sides and angles that are opposite to each other. Use the cosine rule if you have two sides and the angle between those two sides and you want to find the third side. Or you have all three sides and you want to find the missing angle. Now let's look at a complex past paper question that puts everything together. Two radar stations at A and B track a ship at position D. Station A is 8 kilometers from station B. Angle DAB is 42 degrees and angle ADB is 68 degrees. A port is located at C where BC equals 10 kilometers and angle CBD is 35 degrees. Calculate the distance from the ship at D to the port at C, distance CD, correct to three significant figures. Let me break this down into clear steps. To find distance CD in triangle BCD, we know side BC equals 10 kilometers and angle CBD equals 35 degrees. But we need a second side in triangle BCD. Notice that side BD is shared between both triangles. So step 1 is to find side BD using triangle ABD. In triangle ABD, we have angle A equals 42 degrees, opposite BD, and angle ADB equals 68 degrees. Opposite side AB equals 8 kilometers. We have two angles and one side, so we use the sine rule. BD over sine of 42 degrees equals 8 over sine of 68 degrees. Multiply by sine of 42 degrees. BD equals 8 times sine of 42 degrees divided by sine of 68 degrees, which equals 5.3535 divided by 0.9272, which is approximately 5.774 kilometers. Now step 2. Find distance CD in triangle BCD. In triangle BCD, we now know side BC equals 10 kilometers, side BD equals 5.774 kilometers, and the trapped included angle CBD equals 35 degrees. Since we have two sides and the included angle SAS, we use the cosine rule. CD squared equals BC squared plus BD squared minus 2 times BC times BD times cosine of angle CBD. Substitute our values. CD squared equals 10 squared plus 5.774 squared minus 2 times 10 times 5.774 times cosine of 35 degrees. CD squared equals 100 plus 33.339 minus 115.48 times 0.8192. CD squared equals 133.339 minus 94.599, which equals 38.740. Take the square root. CD equals the square root of 38.740, which is approximately 6.22 kilometers, to three significant figures. By breaking the problem down into two steps, first using the sine rule to find the shared side and then using the cosine rule for the final distance, we solved a multi-step exam problem cleanly and accurately. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.